find M1, that is M divided by M1. What is there at M? It is 105. How I am going to substitute the value? It's going to start from 1, then next time 2, next time 3, up to n. If I consider any moduli, they must be prime number. Then what is prime number? The number which is divisible by 1 and its. Hello to all, a warm welcome to my new session on third unit, and the topic name here is Chinese Remainder Theorem. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to my today's session, let me to recall the things what I have covered in my last session of this unit. So there I started with output feedback mode, then I explained counter mode. Along with that, I covered RC4 as well as A5 bar 1. These two algorithms comes under stream cipher, whereas output feedback mode as well as counter mode comes under block cipher. And from the examination point of view, these two types are very important. Now, in my today's session, I'm going to deal with Chinese Remainder Theorem, and this is also one of the very important topic under this unit. Now, let's see what is Chinese Remainder Theorem or CRT theorem. So here the Chinese Remainder Theorem is used to solve a set of different congruent equation. So as the statement itself indicates that it is mainly used to solve different set of congruent, and if I consider this equation, I'm going to have different congruent statement or different congruent equation with one variable. So here I'm having 1, 2 and n number of different congruent statement, but what about the variable? So here variable remains same. So all the congruent uses only one variable and it is x, but different moduli. See here, I'm having different moduli as well as different equation. And what about variables? Same variables, which are relationship prime. That means if I consider any moduli, they must be prime number. Then what is prime number? The number which is divisible by 1 and itself are called prime number. So here we have different congruent equations as well as different moduli where my variable remains same. So dear student, let's see the formula for CRT. So this is the formula and you need to remember this formula. Okay, fine. Now see here, this A1, A2, A3. From where I'm going to get? From the previous slide. Okay. So from the equation, I'm going to get A1, A2 and AN. This is nothing but the different congruent equation. And what about M1? M1 inverse I want to find. So to find M1 M inverse, I'm going to have the formula. The final formula for CRT is x equal to A1 M1 M1 inverse plus A2 M2 M2 inverse, and it's going to continue, and mod M. Okay, fine. So what is this M? I want to find the M. And to find the M, what I want to consider? I want to consider the different moduli. So what is moduli? That is my M1, M2 up to Mk. Fine. Now m equal to m1 into small letter m2 up to small letter mk. Now to find m1, I'm going to have m. I got the m. From that, I'm going to divide m1. And for my m2, m divided by m2 and up to mn. Now, to find m inverse, so to find m inverse, what I'm having, that is m1 into m1 inverse equal to 1 mod m1. So, this is my moduli. And what is this m1 inverse? I want to substitute the value. So, I'm going to start from 1, 2, 3 up to n. So, I want to get relative coprime. That much time I want to substitute the value. And how I'm going to substitute the value? It's going to start from 1, then next time 2, next time 3 up to n. And this is for m into m2, that is m2 inverse equal to 1 mod m2. And for m3, it is m3 into m3 inverse. So, it's going to continue up to mn. So, dear student, you must remember this formula. Along with that, how to find m and how to find m1, m2, m3 and how to find m1 inverse. This much formula you have to remember. Now, this is the problem I'm going to have. Okay. Now, I know what is CRT. Now, I know what's the formula and what are the things I need to substitute. Okay, fine. Now, I'm going to have the formula. Okay. Now, as the CRT definition, I'm going to have different or group of congruent equation. See, I'm going to have 3 congruent equation and one single variable. So, what is my one single variable? That is my x. Now, this is my moduli. So, x congruent to A1 mod M1. X congruent to A2 mod, it is small letter M2. And x congruent to A3 mod M3. So, this is the equation for this problem. Okay. Now, I want to solve this problem. How can I solve? So, dear student, please take a pen and notes. Please write down the steps. Now, first, what I want to do, I want to write the CRT formula. Think that I have written. Okay, now here this formula mod M in Chinese remainder theorem, we have different congruent equation. And if I consider my example, okay, this is the CRT equation. For that, I am going to substitute the problem. See, so my first line in my problem is nothing but it is A1. And if I consider second line in my problem, then it is A2. So, dear student, if I consider third line in my given problem, then it is A3. Now, what I'm going to do here, to make it easy, I'm going to construct the table. Okay, so I'm going to construct the table. So, here at the beginning, I'm going to have given. That means these much variables I'm going to get from the question. Okay, now I want to find these many variables. Now, if I consider my example here, see, this is my A1, M1, this is my A2, this is my M2, this is my A3 and this is my M3. And I'm going to substitute these values in their respective position. Now, A1 equal to 2, A2 equal to 3, A3 equal to 2 and small letter M1 3, 5 and 7 and all three numbers are relatively prime number. So dear student, I got A3 and M3. Now I'm going to construct a table. So this is my table. Okay, so here I have given field as well as to find field. I have given field as well as to find field. And here I'm having A1, A2 and A3. Here I'm having M1, M2 and M3. And I want to find capital letter M1, M2 and capital letter M3. And I want to find the M inverse. So what I'm going to do? I'm going to write the corresponding values to corresponding field and see here 3, 5 and 7 are relatively co-prime number. So all three numbers, that is 3, 5 and 7 are relatively co-prime number. So dear student, if I consider 3, it is divisible by 1 and 3. And if I consider 5, it is divisible by 1 and 5. And if I consider 7, it is divisible by 1 and 7. And all these three numbers are relatively co-prime number. Now, let me to solve this problem because I have constructed the table. And what are the things I need to find out here? At the beginning, I want to find M. Okay, to find M, what is the formula I'm having? That is M equal to M1, M2 and M3. That is my moduli. So what I'm going to do? I'm going to multiply. So 3 into 5 into 7, it is 105. Now I got the M. From that, I'm going to find out M1, M2 and M3. So what is the formula? To find M1, that is M divided by M1. What is there at M? It is 105 divided by 3. So 35. And if I consider second one, 105 divided by 5, it is 21. And if I consider third one, it is 105 divided by 7, it is 15. Okay, now what I want to do? I want to construct a table and I am going to place the value. So M1 35, M2 21 and 15. Okay, now I filled my table. Now after that, what I want to do? I want to find the M inverse. I want to find the M inverse. Now to find this M inverse, I'm going to have the formula. That is M1 into M1 inverse equal to 1 mod M1, and for next equation 2 and for next equation it is 3. Now I want to substitute the formula. So here see at the step 1 I am going to have M1. What's the value of M1? It is 15. And what is small letter M1? It is 3. Now I'm going to apply the formula, that is 35 into M1 inverse equal to 1 mod 5. Now I'm going to substitute, that is I'm going to start substituting from 1, 2, 3 and it's going to continue. Okay, first I'm going to substitute M1 inverse equal to 1. So 35 into 1, it is 35. Okay, 35 divided by 3. 3 ones are 3. 3 ones are 3. Okay, so 2 is remainder. So it's not relatively co-prime number. Now what I will do, I'm going to increment M1 inverse by 2. Now it is 2. So 35 into 2, it is 70. 70 divided by 3. So 3 2s are 6. Then 1, 0. 3 3s are 9. So 1. Okay, now this is the relatively co-prime number. Now what I want to do, what's the value for M1 inverse? It is 2. Okay, now till now you understood, right? Fine. Now dear student, let me to erase this one and let me to consider next variable M2. Dear student, now I want to consider M2. That means I want to find M2. Okay, for that I know my given M2 equal to 5 and I know my given capital letter M2 it is 21. Now I want to find out M inverse. And how I'm going to find out M inverse? That is nothing but I'm going to start substituting from 1 to up to n. Okay. Now I want to find M2 equal to what is M1? It is 21 and first time I'm going to substitute 1. Then mod 5. Okay, so 21 modulus 5. What is the remainder? It is 1. So what is the value for M2 inverse? It is, what is the value here? It is 1. And where I am going to substitute M2 equal to 1. That is nothing but M2 inverse 1. And what about M1 inverse? It is 2. Now I got M1 inverse and M2 inverse. Now I want to find out M3 inverse. Now to find out M3 inverse, what I am going to do? I am going to erase this. Okay. Now dear student, let me to find out M3 inverse. To find out M3 inverse, what are the things I required? I required M3, that is 15, and small letter M3, it is 7. And I'm going to start substituting values to M3 inverse, and my value starts from 1, 2, 3 up to n. So initially what I will do, I'm going to substitute 1. Okay, now 15 into 1 mod 7. So I'm going to get 15, that is divided by 7. 7 2s are 14. So what is my remainder? It is 14. So it is co-prime number. Now where I'm going to substitute this value, that is where I'm going to substitute this 1, that is to my table. So I'm going to substitute the value 1. Okay, now my table is filled, but what is remaining? I want to find x. Now I calculated M as well as M1, M2, M3 as well as M1 inverse, M2 inverse and M3 inverse. Now I want to find out x and I'm going to substitute all these values in my equation 1. Okay, after substituting I'm going to get 2, 3, 3 and I'm going to perform modulo operation, that is 2, 3, 3, 1, 0, 5. Okay, now when I divide this number by 105, I'm going to get the remainder 23. I'm going to get the remainder 23 and that is my x value. Okay, this is the way we are going to calculate Chinese remainder theorem, and it's better to go with table representation in order to avoid confusion. So dear student, in my today's session we studied what is CRT and how to solve some of the problems which comes under CRT. But in my next session, I'm going to deal with asymmetric key crypto system. So dear student, thank you for watching my session. Let's meet in the next session with more information about asymmetric key crypto system. Thank you.